Do I see it yet? There we go. All right. I'll adjust the camera as we go. I am here a little bit early trying to get things going. Okay. Oh, did they take out the goals thing? Oh, they did do it. Okay. Let's see here. Let's see. Everyone's going to go like, what's that goal for? Hold on, we're getting set up here. All right. So, what mysterious thing are we doing today? I'll show you shortly. And yes, it's going to get warm in here fairly quickly. So, we're going to... It's not bad yet. Where is that thing? I had my temp gun here somewhere. Where are you? I don't see it. Okay. So, what we're going to end up doing... Oh, what does it say? Okay. That is interesting. Their hunting state, land. I'm not sure how it's relevant to a drone, but I'm welcome to the chat, you know. Welcome to the live. Oh gosh. Allergies, allergies, allergies. Okay, what we're doing today is obviously we have this drone sitting in front of us. The motors came in. I did a short on this to kind of explain what we're doing. So what we're going to do is we're going to install these motors in. I think I have everything set on the flight controller side. I literally got tired of making connectors to go to the ELRS, so I just soldered the ELRS receiver straight to the pins, and it's interesting because they matched up, RX to TX, TX to RX, so on and so forth. So it was kind of convenient that actually worked out that way. This is a SpeedyBee F405 wing mini. It is sitting on top of a APD 500X power distribution board, and we have iFlight 80 amp ESCs. These are 6S motors. The whole system's going to run on a 6,000 milliamp pack. We've seen this before. You've seen it in a couple different versions of this from the Strike Concept Drone playlist. So give me a second here, and we are going to... I'm going to start doing the thing that people who buy EDFs cringe at. Don't worry, these cases are expendable. It's the motor and the blade that you want to keep together. So... Alright, so today what we're going to be doing is basically just removing this intake lip here, because we don't need that. We'll just we'll set that aside for something else. And then I have to remove tabs. Because, and everyone's like, well, why didn't you just include tabs in your design? Because I was designing it to a purpose. And we'll hold on to these just because if I put it, if I end up using more of these or using some of these, I kind of want to keep this one together instead of pillaging it, you know, for parts. For any other projects, so we're not going to do that from now on. Otherwise, I'd still have this completely built as is. So what we're going to end up doing now is installing these motors, but I have to do some stuff that are going to make EDF people cringe. You ready? There's one. There it goes. Okay. There's two. And like I said, these motors are on Amazon. They're called PowerFun motors. You can get them in 4S, you can get them in 6S. These are 6S 2300 kVs. And the cases you can buy separately, so they're kind of sacrificial in this build. Thermal time, hold on a second. I'm doing this in low light. And the idea is that, let's make this a little bit lighter. Pull this battery out of here for now. This is the battery we're running on it. All right. So, go ahead and get her installed here. We'll do this one at a time, obviously. Like a glove, let's hope the wires reach. Because I kind of had to make modifications for that. If we have trouble with any of them, we'll have to extend them. But that's okay. Now, these EDFs will definitely do the job that we're looking for here. One more on this one. I know I started a little bit early. I said I was going to do this at 1. But it's going to start getting warmer in here pretty quick. So I wanted to kind of do this quick. So that's one installed. And that's going to be freaking cool. Now, since these are sacrificial, one thing I do like to do is I'll come back here and I'll drop a tab of CA just to prevent yaw from the motor. Right on the case. Like so. I know you can't really see what's going on here, but you will see the result because we're going to fly it in here. Alright. Good. We got that one in there. Okay. Let's go with the next one. Yeah. See, it has its own intake lip. That's what's gonna make it easy. It's weird because I can barely see what's going on here, but you guys can see just fine. Thanks for the sub. I appreciate it. I'm glad you're here. I'm doing things to EDFs that are going to make people who like to fly EDFs just lose their minds right now. So when they see me clip those tabs off, sometimes they lose it. They're like, "What did you do that for? That's an indexing tab." are those. What specifically? This is a drone. Yeah, this is a drone. I've got a fairly bigger drone here behind me. You guys will see it because when I put this on the floor, you'll be able to see the Strike Heavy. That was my DARPA drone for the DARPA competition. I was Team 909, but I didn't get to go to Dayton because I had my flight controller take a dump on me right before I left, and I couldn't order one in time. So I talked to Mr. Smith down there at DARPA, and he understood. So I'm going through other programs to do some bigger projects. Well, using the same one, but refining it. It's flight worthy now. I got the flight controller replaced. More grinding. Oh, hello, Evan. How are you? Our friend Evan has returned. My favorite troll. Alright. Locked in. Good to go. Now I'll just make the wires reach. Lord, I can barely see with this lighting. You guys can see just fine. I can't. But if I make it any brighter. The heck, man? I'm not sure what mood you're referring to there. Yeah, it's Evan again. My favorite troll. I always expect you to come in here with something. I mean, come on. You haven't ever really had any meaningful conversations with me. Usually just insulting me. So, yeah. I mean, if you can't take it, don't dish it out. Alrighty. We still appreciate you, Evan. Still appreciate you. Alright. That is those two. The reason why I went with these particular EDFs is because they're the only ones that you can get in 70mm off of Amazon that's has counter-rotating props. So, and they're not that expensive, so when you're doing stuff like this, you're like, I just want to, like, you know, mess around, do some experimental stuff. $40, $46 a motor. And the whole thing, you know, not just the motor, but the whole thing. Yeah, the casing, the fan, everything already balanced. Good to go. He always calls it the Clunker 3000, no matter what I'm working on. You drive a Prius, don't you, Evan? All right. So yeah, I did put the chats on slow mode just because I want to be able to answer everybody, but still concentrate on the drone. Locked in. Good. Good. Alright, now. I know this one I have to reverse. These I have to reverse on the front. Yeah. I think I've been waiting for these motors for like months. If you remember, I brought up this project a while back, actually. And I was like, I can't wait till the motors get here so I can actually do this. Alright, let's get this. Little yaw tab. I try to use the CA glue as kind of a, almost like a, just a welding tack weld, just so that the engines don't try to yaw inside the nacelles. So far we're doing good on the motor orientation. We'll find out. I've done as much pre-programming as I can to the flight controller. Ford Escape. That's like the SUV, isn't it? Is that the? I think it's an SUV. Another way. Well, you can't blame the U.S. I mean, you bought it. Half the stuff's made in China anyway. I know that because when you work on an American vehicle and have to use metric, there you go. It's going quicker than I thought. I hope that's not a precursor to a horrible thing. There we go. And roll. Let's see here. Now the one thing I did for heat mitigation is I replaced the lines that I had. Hold on, I can't see this. Okay. I replaced the lines that I had that were, you know, that copper-clad aluminum or whatever. Or whatever they use on these traditionally. And I replaced the lines going from the power distribution board to the ESC, and then from the ESC to the motor input wire with solid copper or solid copper, was it 8 gauge wire? And that was because I didn't want, you know, heat soaking. I was trying to avoid the overheating. All right, let's get that tacked into place here. Little CA tack. All right. Well, was easier than I thought. Alright. Let's do this. Out of the way, out of the way. We don't want anything getting pulled in there. Power up the radio.
Welcome to HTX.
So, let's see what she does. Okay, double check everything first. Everything seems to be okay. Receiver's good. We have. Let's make sure we get connected here. All right. Yes. This one's blowing the wrong direction. Hold on. Let's try that again. Hold on. Yeah. I gotta switch one around. Hold on.
Telemetry lost.
I knew there was going to be one at least that I'd have to switch. All right. Well, I'm going to cross this wire under. I made these a little short. Please don't be my downfall today. There we go. We did change the capacitors on these. These standard iFlight ESCs did come with different capacitors, but I wanted to avoid ripple current and smooth out the power, so went with a different YXF capacitor.
Telemetry recovered.
Did we lose telemetry? Slow down. That was freaky. All right, let's see what happens here. Started going up. I was like, wait a minute, hold on. Oh. Okay. We don't have. Oh, that's why. Okay. Yep. All right, let's fix that really quickly. All right, where's my... That was a signal loss. So what I was trying to do was go up and land and do the return to home. Whoo! That was close. That's why I pulled the power. I was like, she's getting ready to take off and then try and land. I need my magnifiers. Where do they put that? Okay, hold on 1 second. I gotta find it. Where are you? Let's see. Let's do this. Typically, I use this light here for magnification. Hopefully, you guys can still see what's going on. What did we lose? Oh, I see. Well, That should be fairly easy to fix. I just mentioned the pins too. I was like, I did this with the pins because it's easier. Soldering gun. We just need to heat it up. Hook up the soldering gun real quick. All right. All right. Let me get this fixed really quick before we try to take off in the garage. We're heating up. Sorry. Where's my solder? I need a little bit. Yeah, that we don't want. No signal losses. No signal losses, please. Go. Ah. Good. All done. All right, back to me. So, quick repair. Well, that's what I did, is avoid wires altogether. I just went straight from the actual board itself to the pins. I just hope it's I hope it doesn't lose signal in the garage. That's the only problem.
Telemetry recovered.
There we go. Why are you doing that? Barely touched the throttle. All right. Make some room and get it on the floor, huh? And then we'll move you guys. Actually, it might just be doing that just because it's. Now, this is where I'm going to have to end up moving the camera over to here while I put the drone over there. So let me get things moved around. Flying this indoors, probably not a good idea, but it should work. At least for a test hover. The great part about all this is the plastic's basically sacrificial. All right. You all see that okay? This is gonna make me nervous as hell. It's like literally the maiden of this version. And I know it's probably gonna need work. So. Hold on. Let's get it back over here. Let me turn this fan off for a second. All right. We're getting it. Outdoor flights are usually easier because I don't mind if something happens and it flips over. Okay, we got to work on the PID loop. And something smells nice and cooked. I'm not sure what it is. Okay. It wants to yaw to the right slightly. So maybe we can adjust that in the trims. Keep it from doing that. All right, she's working, but obviously the PID loop is got to be worked on for sure. You can smell it. What is smoking? Oh my gosh. You know what I'm wondering? You see the motor smoking? That's never done that before. It didn't do it on the first one. I wonder if my brother accidentally ordered the 4S motors. Because if he did, I'm getting ready to burn them up. Wow. I'm going to have to check the orders. That's insane. I knew I was smelling a motor, but I'm kind of wondering if they sent me like a 4S on accident and I'm just overamping it. But it seems to be working okay. I'll check with the thermal camera here in a little bit. I'm kind of wanting to see how it's working. Now that it's obviously definitely needing some PID configuration, but I'm getting the hang of it. Okay, well, it's working. I said I was going to do it live. And I said I was going to do it for everybody. We'll see. We're going to keep going. And then off screen, I'll be doing PID adjustments and stuff like that.
0 miles per hour.
Okay, well, that's my telemetry. Yeah, did you hear that? These motors are brand new. I think one of them bad. Unless he got 4S on accident. I don't know. I told him which ones to order. It might just be that. It sounds like it's that left rear motor. Yeah, you can hear that motor when I shut it off. You hear that? See if I can center it up a little bit more. This is Cosmo line heating. So, yeah, I was live. What happened? Okay. Hopefully I still am. So, it did work. What in the world is that in there? I'm seeing something in there. Hold on. Is that a piece of plastic? Is this thing melting itself? No, hold on a second. All right, let's come over here to the bench. We'll figure this out. There is, and give me a second. I'll get this set back up. And then I am going to turn my fan on. It's warm in here. Okay. There's something down in this motor. I don't know what it is. I don't know what it is. But did the other one have the same thing? No. The other one seems to be okay. But this one has some kind of... The hell is... Ow! That's hot. Alright, let's check thermals. The motor shouldn't have been getting that hot. None of them should have. I think these are 4S. But it didn't say it on the packaging because it's Amazon. Thermal cam. Alright. Motors are sitting at 161 Fahrenheit, 163, 168. This is heat soaking, of course. I'll bet these are 4S. I'm going to have to pop the motor out. You couldn't tell because it was covered. 150. I mean, I guess that's okay as far as operating range goes, right? 161. Maybe that's a little high. I still don't know what that plastic is that was burning off of there, unless it was just a molding defect on the blade. But still, I think these are... What the frickin' heck is that? Alright, tweezers. Tweezers. Get out of there. What in the world? What is that? Whatever it is, it's melted. I wonder if they just put it together the wrong way. No, these have to be 4S. I don't think these are 6S. I'm gonna have to yell at my brother now. Thanks for ordering the 4S motors. That's okay. That's the cool part about this project, is you can just pop in the motors, pop them out, plug them up. Everything seems to be working as far as flight goes, even with 4S motors. Yeah, they're warm. They're a little bit warm. Let's see what it does when I arm it now. those don't act like, I mean, they feel like they're doing okay. There's no, they still feel fine, which leads me to believe these are not 6S. And I didn't want to take one apart because they're dynamically balanced. So the idea was run them as they are, and you can't see the whether it's a 6S or not underneath the motor housing, because the motor housing is too long. So the way you end up having is see, they didn't sound like that when I first booted it up. Evan, I don't think you could. If you've seen the first one on the Drone Power Concepts playlist for the Shrike Concept drone, the FDE green one, that's the one that I flew at the park. It was 6S motors for sure. And what kind of threw me was the ones I had before had the white markings on the cone to show that it's sealed after it's balanced. And I think that's what the problem is, that these are 4S. But it still flew, pushing 6S through it. So I'm going to go ahead and get the other ones reordered so we can do this again. And get the right motors here. So, but it flew, even though it was pushing 6S through a 4S motor. Or I'll try a different brand. I mean, maybe I'll try a different brand for it. The other one flew really, really well. Had lots of fun with it at the park. It was just one of those situations where at the time I was on a tight budget and I was forced to kind of take that one apart and use it for other projects. But yeah, you'll see it. It's the Shrike Maiden. I'm at a baseball field. It's an FDE drone. If you look on that playlist, you'll see it. You'll also see the original white ones that I used, that I printed on an Ender 3, which was really cool because that printer actually worked really well. And then I switched to a Bambu Lab X1 Carbon, which kind of opened up a whole new realm of possibilities for me. Which is why this particular idea spawned the 5-foot drone that's sitting out in the backyard because I don't have room for it. Yeah, that was a good run. Capacitors are not that hot. The ESCs were doing their job. Why is there a light on that ESC, but not on the other ones? That's odd. I wonder if that's an indicator of getting warm or something. Have you ever seen this before? On these iFlight ESCs? It's not coming on the other ones. The other caps don't have a light on them. Sorry. It's literally... Second here. Hold on, it's coming back up. There we go, sorry. No, these caps, the lights aren't coming on. That one is. That's weird. I'm gonna have to check all of my filters. Something's going on with that one. I'm gonna have to look up what that means, because this is the iFlight, I think the EVP B3 80 amp. The light coming on is kind of weird. I'm not exactly certain why that LED is on. It's a mystery to me. So we'll get to that one for sure. That's the one that sounds the worst. These sound okay. Except for that one. That is interesting. I wonder if braking is on. Well, it flew. Yeah, I'm definitely going to have to look into that and see. And then we'll take this one out to the field at dusk and kind of enjoy the lighting. That was really interesting. That was super interesting. I also had to get this one out to the field. The wings for her are up here. And I've got other drones I'm working on. This is the DARPA drone here. And this is another one I'm working on. You probably recognize it. Everyone had a fit about it when I posted it. Somebody like posted a comment and said, "That's a weapon, genius." I'm like, that's like saying a P-51 Mustang model is a weapon. But yeah, people tend to overreact with stuff. That's for sure. But she's almost done. And then we've got this girl going with the. She'll be running those props, 40-inch. This is the one that we had for the DARPA competition. It's a 100-volt system. I'm running a buck converter, which runs the Tico 32, which runs the actual tip motors for my control authority in the air. So that's actually how it stabilizes in hover mode, keeping the wings earth frame level. And then once I go up to altitude, everything rotates. So yeah, that's how she works. Those batteries are expensive, super expensive. So yeah, we have a lot invested in this one. So one of the things we'll be working on for search and rescue operations and things like that, maritime search and rescue, dropping supplies, comms, dropping inflatable raft systems, that kind of thing, for emergencies, pulling people off of houses and floods, things like that. It's kind of where I'm with that one. That's why I have the much bigger batteries. And then I want to get that glider out to the field. This apparently, I thought this was a fairly newer glider, but I haven't been flying gliders for a long time. I had a Super Sky Surfer, don't blame me. But I got the Phoenix. We're going to take it out to the field. We'll get some footage of that. And I am going to be eventually moving. So there's a chair there somewhere. But yeah, I'm going to be definitely moving. Maybe in a couple of months. And I have a bigger garage. Good Lord, Evan. Don't you have anything else? You always come up with the same stuff. I don't have a girlfriend. I have a wife. But yeah, so the plan for this one is we're going to go ahead and check these motors because they are not.
Telemetry lost.
They're not. There's a cap of the resolder on there. I just did that. Did you see the spark? These connectors are too tight. So she flew okay, hovered fine. The motors got hot. That tells me that they were 4S. Not 6S. And I thought that because they were saying, no, it's a 6S motor, but it's 2300. I'm like, no, it can't be 2300. Maybe 1900 kV, 2100 kV, but if you get in 23, it's more than likely 4S. So, I had my suspicions, but I wanted to do this to see if it would work. And if it ended up being 4S, which they are, I'm now convinced of it. Then I'm just going to swap them out. I was going to tell you send me 4S motors, not 6S motors. And since you've covered up the entire engine, the Outrunner's bell, I can't see what it is. I don't need to increase the PWM frequency. All the PID was set. The only thing I need to do is increase the loop slightly, because we kind of had a dead stick area all the way out to about over half of the stick movement. So there was definitely a dead zone that I'll have to address. But see, I don't want to do any of that yet until I get the proper kV motor in here, the proper motors in here. These were, if they're true 4S's, then we're looking at 14.8 on the volts. So we're definitely going to have to switch it out, because 22 is going to give me a different RPM frequency, because it's kV times the RPMs. That gives you, or kV times the voltage gives you your RPMs, and then you'll know how to go from there. So yeah, that's something I have to look into for sure. But we're definitely going to keep pushing forward on this one, because the very first one was like the best one. So yeah. Okay. They have to be 4S. All right. I'm going to text my brother and say, send these back. They gave us the wrong motors. He either ordered the wrong ones or they shipped the wrong ones. So that's why they got hot so quick. Other than that, I mean, the caps didn't get warm, nothing. One ESC light, which indicated that one had a problem because you can hear it. Maybe that's what it was it was telling me which motor had a short or something. I don't know. I'm going to have to look up these iFlight ESCs. I have the manual somewhere, but I'm going to have to look them up and see. They didn't get that warm. The motors are still warm. So that tells me that we got to switch those out. So we will switch those out and do this again. And then once we do this again and we get this kind of stabilized, then what we're going to end up doing is taking it out to the field and flying it like I did with the first one. One of them I was flying out like literally on the street out front of my house. And that was like the first Ender 3 one. That was when I actually ran a 6,000 milliamp battery for the first time, the graphene LiPo. They work really well. But I put this APD 500X and these ESCs through a lot. So I'm not surprised that we did have some issues. The fact that I was able to just kind of throw these in there and get this thing off the ground was really cool. I mean, it was a quick turnaround. So we're going to definitely revisit it for sure. Well, the throttle control was fine. It was just it's the PID. We had originally set the PID low, so there wouldn't be any overcorrection, because on my first one we had a little bit of overcorrection on the yaw authority, but it still flew really well out at the field. So what I want to concentrate on now is making sure the hardware is perfect first. Making sure all the solder joints are good, and making sure everything's good to go. And then we're going to go put those 6S in there, because I guarantee you these are 4S motors. And then we're going to go from there. Do I have a 4S I could test it with? Probably not. Well, I do. Probably not the right connector, though. This is an XT90. I went with an XT90 because I was carrying a lot of heavy current through here. Because you have to divide all that current up between, all these motors. You're looking at 4S is higher than the 6S on the current. So you can't run it off of a 4x stack with a standard capacitor. So when I use the wing, and then I piggyback with a 500 APD 500X, which can handle 500 amps of current, and I run the telemetry from that for the battery to the telemetry UART on the actual wing mini, and that sends the voltage to the transmitter so I can see how much power I have left. Things like that. So, but you can't run these off of a traditional 4-in-1 ESC stack. The current is too high, you'll blow the capacitors every time. So you have to have a power distribution board that can handle that kind of current. And I'm actually kind of impressed that it actually worked well, even though these are 4S. Because 4S delivers a lot more, it requires a lot more current. Lower voltage, more current. I use INAV. I've already done all that. I'll definitely be checking out, you know, RPM, the gyro filter, all the other filters that are on there, and then I'll be raising the PID. Probably not very much, maybe 5 or 10% at first, just to see if I can get that yaw authority and responsiveness back, because it tended to cut it down to where you only had it about halfway through the roll. So if I rolled or yawed, I was only getting a response around halfway across the stick's throw. So there was that dead zone in there for that. So we can fix that easy enough. What do you mean I have no idea? I was right here flying it. I was flying it and I had my hands on the controls. So I know what's going on. But yeah, that's what we're going to do. We're going to go ahead and switch these out to the proper motors. For certain that these are 4S now. And then we're going to go ahead and switch those out, and then we're going to fly it again. And then I want to get, eventually what we're going to end up doing, it might not be live depending on where I'm at because of the signal, but I'll be recording the strike going up. That's going to be a fun drone. 9-foot wings, 40-inch props, 100-volt system. I definitely want to get some video of that. I want to fly the glider and record some of that. And then the problem is I'm the only pilot in this. I'm the only engineer, I'm the only builder, I'm the only pilot. So I don't have anyone to fly the Avata 2, so I can get some aerial footage of the drone. So I need to hire somebody to run the Avata 2 who knows how to fly an Avata 2. I use the Motion 3 controller, which is really cool. Way easier to fly than I thought it was going to be. Never using a one-handed controller before. But yeah, I've had some fun with that one. But I want to get my glider up, and I want to get the Avata up, and get some aerial footage, things like that. So I'm definitely going to have to hire somebody to actually, you know, operate the Avata. And I have a friend of mine that can probably do it, but I don't know if he's down south again or not. But you know, Bird's Eye Aerial Drones belongs to my friend's brother, and he actually gave me a lot of the Cinewhoops and stuff like that, and some water bottles and stuff for his company, and some shirts and some hats and stuff like that. So he kind of is supporting me in what I'm doing, and that's really appreciated. So like, if you need any work done for land surveying, anything like that, check out Bird's Eye Aerial Drones. Look up their website. They can hook you up. They've got everything they need to do whatever job you need done when it comes to drones. Inspections, land surveying, anything at all. I mean, Scott is like the man when it comes to that kind of stuff. And he knows what he's doing. And it's a veteran-owned business, so you're going to be supporting veterans. I'm a veteran, so I know what it's like when you're first starting out. He's been working in his business for a while now. But yeah, he's a good guy, solid guy. So if you need drone work done, bird's eye aerial drones. Again, bird's eye aerial drone. But that being said, this was fun, even though we got the wrong motors. And I knew it because when I landed the first time and that smoke started coming. Did anyone else see the smoke coming out of the top of the motors? I was like, that's not right. And then I thought back and I go, did you say 2300? No, they can't be 6S. No. We need to do this in a 90 or a 120 millimeter version. And all I have to do is increase the nacelle size when I do the print and go from there. And then I can make it a little bit taller. But yeah, I'd love to do a 120 or a 90, but those things are expensive. And it's mainly because the availability of counter-rotating prop EDFs are really hard to find depending on what you're looking for. So if you go on Amazon and like I did, and you get these motors, they're not that expensive, but you can find counter-rotating props. When you start to get into the higher millimeter sizes, like the 90s and the 120s and things like that, you end up coming in, up against a wall because you can't find, with some of these manufacturers, it's hard to find counter-rotating props. So, because, making the engine spin the other direction is easy. But getting the blades that are designed for that EDF, when you go up to the higher sizes. And I know JP Hobby has some really good ones. They're all aluminum. They do have counter-rotating. But they are super expensive, which, I don't blame them because they're really good quality. If they send me 4 120s on that and, 2 pairs, I'll put together another one with those, and that'd be some fun. That would definitely kick some dirt for sure. But that was fun. I enjoyed that. I hope all of you enjoyed that. What we want to do at this point is basically thank everyone for stopping by. Evan, we will go over those RPM frequencies and we'll see what we've got, and we'll check out the logs and we'll see how things are going. Black box logging is going on, so we'll be able to see exactly what was going on, and I'll be able to tell by the current for certain that these are 4S. I really don't want to take them apart to verify it because I want to send them back whole. I don't know what that plastic piece was that came out. That's definitely something that happened on their manufacturing end. Some extra blade part or something, or extra mold that kind of got stuck in there. I don't know. You tell me. But yeah, that's not normal. So yeah, starting to return on this one. But that being said, it was a good flight for kind of just jumping in with the PID setting, kind of guesstimating everything, and then getting it in the air. Had a little bit of oscillation. Flying it indoors obviously is a little bit harder because there's less room for error, but it worked well. I was impressed with the performance, and this is the first time I have used a 405 Mini. A lot of them have been the 405 Wing V3, full size ones, but I figured the Mini was adequate, and I did do a TPU block underneath the flight controller to kind of mitigate some of the vibration, so I wouldn't have to adjust the filtering so much. So that helped. Now, I don't know if these new YXF capacitors had anything to do with it. They were meant to sort of smooth out the ripple current and to kind of be more stable power. So that was a suggestion by somebody to actually install these, as opposed to the original capacitors that came with these iFlight ESCs. So I might swap them back out for a set of originals just to see the difference. Not with these motors, but for sure just to see if there's a performance difference. And then I'll have to check and see why the light came on that ESC. So as it stands now, what we're going to do is get these motors replaced with the right ones, and then we'll go from there. So now we have some extra motors here. I think they're in pretty good shape. I didn't see any windings getting burnt. The battery definitely got warm. Damn, it's still warm. Yeah, that has to be 4S. A battery this warm. Whew. We've been sitting here talking for what, 5-10 minutes. 122 degrees. I don't know if you can see that. Dang. Yeah, that battery almost went thermal. These are definitely 4S. That's all I needed to know right there. Let's get you over here on the ground where you can cool down. Wow. Yeah. No, it's not gonna pop, but it definitely got warm. As you can see, there's no deformation in it, no bubbling. Battery's still in good condition, and the graphene lipos tend to withstand heat a little bit better. But it did get, I mean, if it was still 122 after 10 minutes, it must have got up there. So yeah, that tells me right there that they are definitely 4S motors. Definitely have to be. You're not going to get heat like that out of 6S motors when you're running a 6S pack. It means it was pulling more current, which was demanding a lot from the battery. And even though and that's a 120C battery, or 100C. Was it 100? Yeah, it's 100C. It's 100C. So if it got hot, these are definitely 4S. Now it's not rising. It's kind of staying. I mean, I'll check it in a few. But I think the battery's okay. That battery's been really good when it comes to being abused, taking a load, you know. But yeah, wow. Well, that's definitely a telling sign. And the light coming on this ESC, not these for some reason, but the one that lit up here, probably an overcurrent sensor. I don't know. I'll have to look at the instruction manual for these ESCs. I just never bothered. But these are the ones that flew in the original EDF drone. That would be the green and FDE colored one that I flew at the baseball field. You'll see it in this playlist, the Strike Concept Drone playlist. You can't miss it. It's in there somewhere. You'll see the green field and where I flew it, and it worked really well until I started messing with stuff and then using it on other projects. But yeah, that's what it's all about. You know, you build it up, you make it work, and then you kind of push the limits of it. But this one spitting out plastic pieces is definitely a telltale sign that something was going on. So, but they all still, the magnets and everything still feel really good. And I don't think the windings have any discoloration, or I don't think they're dark or anything like that. Let's take a look. I can't see it with my eyes because maybe a little dark. Yeah, they did. They're not gold anymore. These have to be 4S. They have to. There's just no other explanation. And you can see here, they covered up the whole bell, so I can't really see anything on here. And you don't take apart a balanced motor like this, a dynamically balanced motor. It obviously didn't get hot enough yet to burn through any of the varnish on the windings, on those wires, to cause any kind of short. But it definitely acted like a 4S motor. So we're gonna get that rectified and go from there. And then we'll see how it acts. I'll get some 6S motors back in here and we'll get it going again. Realistically, if I just got the motors themselves, I could pop them in there. But I don't know how it would affect the balance. I do have a magnetic balancer for these props, but that's not how these are balanced. So if I buy just the bare outrunners, I could probably get away with just swapping out the outrunner and then doing it that way. Yeah, I cooked something, man. It was definitely smoking for a second, but then it kept flying okay. But I wasn't anywhere near half throttle for the most part, which is why I kind of had it at a hover. And I think if I would have pushed it really hard, I would have overamped it, and then really finished those motors off. But I think what we'll do is we'll just find the bare motors, some outrunners. These have shaft adapters on them, that I know. So they'll, just find the appropriate 6S outrunner that'll fit inside the bell, inside the case here, and then we'll just swap it out. I'll probably go back to the same company and say, hey, look, you sent me the wrong motors, or they were ordered wrong. I'll have to check the invoice from my brother and see. We need to get the 6S in there so we can get this thing back up in the air. It was fun, and it looked cool. I mean, it was cool. So getting this outside when it's dark and dusk and everything, it's going to be fun to fly with that lighting on there. And that's really the whole idea behind this, just to have some fun. Everyone's going to say, it's not practical, the battery time won't last long. The battery time actually does last a considerable amount of time. Now, I want to ask you if you can guess how many amps or milliamps that I had pulled. This is a 6000 that I had fully charged. So the question is, now, did I kill it? It's the battery's down to 3.7. So that's a good cutoff range, but that tells me, because of the way this flew last time, that these are definitely 4S. Because the way this flew last time, if you find the video, watch it, or I'll go back and I don't know if I can link the other one in the description or not. But and the temperature's dropping. So, yeah, don't worry about it. It's not critical. But, yeah, it did bring it down to 3.7, which tells me, and I had just charged it to 4.2 per cell. So I think that the main problem was that these are 4S and not 6S, like they were supposed to be. And because of that current demand, that's where that heat came from. And that's where the battery draw came from, because the 6S don't pull as many amps as the 4S. But it did show me something. It showed me that APD 500X power distribution board can handle it, because it didn't fail. Nothing failed. It still was in the air, even though it was spitting pieces of itself on the bottom. Which is crazy. So what do you all think? You think 4S? Did I accidentally get 4S motors? I think so. What? This is kind of a... What are you talking about? Yeah, 4S. CG, I agree with you. They're definitely... I definitely was shipped the wrong motors. Because I designed this whole system around a 6S setup. Evan. Why would you ask that kind of question? Are you, like, wearing ear cape or something? I don't do the whole Harry Potter thing, so you're on your own. But I'm glad everyone got to stop by and check it out and kind of see what we're doing. Next live we do, honestly don't know what it's going to be. I don't know if it's going to be the Strike Heavy, the Strike Concept drone, or the Strike Ultra with the main, the big 340mm EDFs. We're still working on motors for those because it's an extremely high disk loading. So we got to make sure we get the right power for that system, for sure. Yes, I had posted that I wasn't there because I had the flight controller. I was running a Maytech H743. Everyone else is probably running an Orange Cube. So I went the other route. But everything was okay until we had something got into the main board and shorted right before I left. And I was team 909. I was scheduled to fly on August 3rd. And I had to write Philip Smith and tell him my flight controller died and it's going to take 10 days for them to ship me another one, so I can't get there. And I didn't have another one on hand. But he still wanted me to come out, and they wanted to meet me in person anyway. But at that point, it was like the investor didn't want to obviously pay to go out there for no reason if we weren't going to fly. But I since have gotten the replacement flight controller and everything's back up and running, so we will be flying it for other programs. I know, we were in the same group. Oh yeah, I think everybody, they even gave us time. If you remember, they sent out an email. They were like, we're giving people extra time for the milestones we were turning in because they knew we were having shipping problems because of demand, and so they kind of extended that. Yeah, I'll be in the next one. I hooked up with DARPA Connect, so I'm gonna be working with some programs with them because there's still a lot of potential for this drone. I just never got to fly it at the competition, it was an honor to be chosen after reaching those milestones and showing the progress and my build progress and everything to them, and them going, getting an invite to DARPA is just something in itself that was an accomplishment for me. Getting kicked in the teeth by the flight controller going out at literally like 2 days before we had to leave, and knowing that I wasn't going to get another one on time, it was just it was sort of soul crushing. But other than that, my design was still accepted into the competition. I met the milestones. It was fun to get that far. I still enjoyed watching the competition. But what I didn't get, now they were looking for new novel designs and things like that, and they wanted to break that 4-to-1 vehicle to weight ratio. But the problem, thank you for that. I mean, I still got her. She's still here. The wings are still sitting above me right now. She's good to go. But I don't know. I want your opinion on this one. I think the helicopter angle was kind of cheating. I didn't want to say it at first, but I'm thinking to myself, if DARPA wanted another helicopter that could do 4-to-1, they could have just built one themselves. I'm not knocking the guy who got the 3.8-to-1. Still really good, but helicopters are known for that kind of lift capacity if they're designed specifically for that. And I don't know, a helicopter winning it kind of just, I don't know. If that was going to be the case, if helicopters were like, you know, what they wanted, I would have just done one. But that wasn't what I was trying to do. I was trying to give a different, new, novel design approach, which is kind of what I think what they were looking for, was to see the ideas. Now, they still got to see my idea and my test spin-ups and everything like that, because you know, they have all that, the video, the information that I sent when I was completing my milestones. But yeah, no, mine's not a plane. It's kind of a mix. It's sort of a plane and sort of not a plane. It's a fairly novel design. My wing loading can handle way over 560 pounds. The 40-inch props I was running at 24S, which is basically 100 volts, I was able to lift a maximum of 220 pounds, which is right on the 4-to-1 mark, but I had no margin past that unless I increased the props or I raised to a different 24S motor and a slightly larger ESC. Then I could have hit 4-to-1 easy. The VTOL segment of the run is what killed you. And that helicopters were able to use fuel, and I don't know. I went full electric because of the way I designed the system. But yeah, I mean, it's a great design, and that's another reason why I need to get somebody to fly the Avata so I can get some footage of it when I take it out to do some flights on it. Because I think I came in at about 53 pounds, but with the wing loading that I could carry well over 500, about 560 pounds between. I mean, it's 9-foot wings with 26-inch cord, Clark Y foil, you know. But I didn't have traditional control surfaces. It was all thrust vectoring. And that was, like I said, to keep those wings level during VTOL. And then during my transition into forward flight, my plan was basically a controlled arc through from the ground up to the flight altitude. And then by the time the arc was finished, we had enough speed for the wings to be carrying the load, which dropped our power consumption considerably in that leg of the mission. So yeah, that was the overall plan. Yeah, I learned a lot watching it online. I mean, I really did. But yeah, it's definitely a vibe I definitely wanted to experience. It was just, you know, after the flight controller, I was thinking, am I still going to make a 33-hour drive? You know, I just couldn't do it. And I thought about just flying out just to be there, but no, I didn't have the funds to fly out there myself. And the investor didn't want to put more to go out there just to sit there and watch everybody else fly. He obviously wanted to see this thing fly. So it's one of the reasons why I went to DARPA Connect in the beginning and decided it was time to go ahead and go for more projects from the site.
Want coffee?
Actually, I still have some. I made some.
Okay.
Thank you, honey. Yeah. That'd be one. I wonder if somebody would take that Uber. I mean, actually, I'm gonna request an Uber for California to Wright-Patterson Air Force Base in Ohio and see what they say. That might be kind of fun. But all in all, it was a great experience from the very beginning. The thing is, everybody had a big team for the most part, or more than one person working on it. And I had to go from conception to design, CAD, printing, acquiring the parts, doing the acquisition of the hardware. I had built this entire thing. I did the entire project solo from the beginning to the end. And I guess that it was more of a personal challenge for me. Took you 4 days? Oh my gosh. See, I couldn't have done that on my own. I'm on vet benefits, so the only reason why I ever got the craft built was because I had somebody, who was interested in the project. But, and that's why I'm moving forward with DARPA Connect, because I know there's still more opportunities there. And when I do the next lift challenge, I'm going to have probably the same aircraft, but slight variation on design. Because I learned a lot from building it. And I had no team. Typically you have somebody doing aerodynamics, you have somebody doing, acquisition of parts and things like that. And I just, doing the programming and all the other stuff. And I had to do everything on my own. And I basically, it ended up being a hexacopter design with 2 large lifting motors. And the 4 tip motors on my wings were my wing stability on VTOL, which kept the wings level. And then they turned into my pitch and roll authority when I'm in forward flight. So I had no ailerons, no elevator, no rudder, nothing. It was all vector thrust. Yeah, it is impossible to do without a team. I had one person that was going to go with me, which was the person who basically paid for the parts. And I had to pay for some, because there were some that I had to order real quick, so I'd have to get them. But for the most part, he handled everything. He was going to be my visual observer there, so it would have been just us 2 there. But as far as the design, the conception, the build, everything, I did everything on my own in this garage. And that was hard to do because I had no fixture tables to build the wings. I did everything, eyeballed everything. And building 9-foot wings with no fixture table, that was a challenge. I had one end of it leaning on the charger for the batteries. When I do one side at a time, and I had a welding table that was just long enough to hold each side as I was putting in the ribs over the spar when I was doing the wing, when I was building the wing out. And then I'd have to flip it around and do it again. And then I had to wrap the wing after I put the D tube together. I actually used the packing foam from the props, because it was a dense extruded foam for the D tube on the front of the wing. And I just epoxied them into place between the ribs, and then I sanded it down to form the front of the airfoil before I wrapped the wings. So, and everything was printed out of PA6 CF15. So I was using the whole thing, these 9-foot wings, every component that holds on the ESCs on the actual aircraft, all that was printed on the Bambu Lab X1 Carbon with carbon fiber reinforced nylon. And I still have yet to hear from Bambu Lab about sponsoring me. I've built the Shrike Ultra, the 340mm EDF. It's a 5-foot by 5-foot EDF drone, 11 blade, 340mm. high pass EDF, high pass fan design for the EDF, but it's only 11 blades. And that I printed on the Bambu Lab X1 Carbon. 28 kilograms of PETG went into building that. And I'm still working with the X1 Carbon. It's been like the best printer that I've ever used. I know that people have had like problems with the new ones that came out, but Bambu Lab hasn't sent me one to try out. So maybe somebody should shoot them this video and say, hey, look what he's doing. Send some printers and some filament his way. He's got some stuff he's got to build. But I like pushing the limits of their printer. And with a 250 by 250 millimeter build plate, which I think the top end's 250 as well. I had to build 2 9-foot wings, a 5-foot by 5-foot EDF drone. Massive aircraft off plate by plate by plate on that printer. And I checked the hours on it a couple of days ago, and I think it was about 8,000 hours on that printer so far. I've had to change the nozzle out maybe a handful of times, 4, 5, 6 times. And most of those was just a change from a 0.4 to a 0.2 to a 0.6. The only other problem I had with it is I had to change out the board on the head where the hot end plugs into and the fan plugs into and the extruder, because I had a solder pads come off of one of the bottom of that. So I got another one of those boards and put it in. Real easy to fix. Keep the lead screws clean, lube them up when you have to. And the thing has just been going and going and going and going for about 8,000 hours now. Yeah, I pushed that thing hard. I pushed that printer hard. It's still going. I mean, it's still going now. My kid, on top of doing the stuff for the drones, my kids wanted stuff, so I would print out stuff for them, print out stuff to repair things around the house if I needed to. I've run the TPU AMS for the TPU for the AMS, which is a lot harder TPU, and it works out well for doing, mats and things like that for soldering and cases that are impermanent. I mean, I've done like waste baskets and stuff like that for the bathroom. I mean, it's like I've done everything on that printer, everything from bathroom fixtures to massive EDF drone. And I think my wife was like, well, we need to write Bambu Lab and let them know, they should probably send you something to try out because of all the stuff you're doing. But the problem with that is I'm only got what, 40-something thousand subscribers, so they don't want to look at you. Are you still on the dollar store foam stage? Foam is easier to build stuff with, and because I thought I was going to print most of the D tube for the front wings, or for the wings on the Strike Heavy, and I ended up using foam for the D tube, and it actually ended up being, I can't remember, it was like a closed cell dense extruded foam. I don't even know what to call it, unless I just called it what it is, because I can't find it anywhere. But they used it in packing the propellers and the 40-inch props for the drone. And I was like, this is perfect for the D tube. I don't have to print material for it. It's going to be a lot lighter. And it ended up working out well. We haven't done the math. I think collectively in our team we spent over $30K. Wow. Are you kidding me? Damn. I guess I was lucky to get away with 15 grand, right? Yeah, foam is amazing. You can do all kinds of stuff with it. Especially with the different types of foam that they have. But clinical waste. Wow. Yeah, foam is good for a lot of stuff when it comes to these kind of aircraft. And even when you're doing commercial grade systems, you can't do it without some foam reinforcements, especially if you're trying to save weight. A closed cell dense foam, extruded foam, is perfect for that kind of stuff. And it's what made my wings so light. Each wing was only 9 pounds. And they're 9-foot wings, so, 1 pound a foot. Not bad, especially when I was running a 40mm carbon fiber spar from Rockwest Composites. I got all my carbon fiber from Rockwest. They were really, really good. They have some high quality stuff. Now, I may have overbuilt the spine of the aircraft with that huge rectangular carbon fiber spar, but it could have been, I guess, a little bit less built up. I didn't need the wing area that I did build, but I didn't want to underbuild it either at the same time, because I was still looking at about 25, 35 miles an hour before the wings started picking up load and unloading the main pushers. Oh yeah, definitely gonna. Yeah, we're gonna show her off. We're gonna get her out to the field, explore. We're gonna get her out to the field. We're gonna get her assembled, and we're gonna get some flight tests done. As soon as I get my friend down here or up here from San Diego, unless he's still in the area, I gotta find out. So he can run the Avata, so I can get some not only ground footage but some air footage as well. She still only comes in, I think it was like 53 pounds, roughly 53 and a half, and that's with 16 amp hours for the 100 volt battery. So it was a challenge, and I had fun doing it. I'll give you a last look at her before we end this stream today, because it is getting kind of warm in here. So we are running, everything tilts forward. These are my motors I was running at 24 volts, my ESCs. This is my tilt mechanism that I put together to rotate forward. And we have one, of these wings up here at the front and one at the rear. And then the main lift system was down here. All my avionics are down there. And then everything was run off of a UBEC. So we could basically just switch it on. Yes, I know. But anyway, it does that when it doesn't find the radio. But yeah, everything was good to go. And these are like the 40-inch carbon fiber spars that were in the wing. They definitely take a load. I was using 1,000-pound strap to basically hold the load itself. So I overbuilt the whole thing. I really did. But the idea was to make sure that I could lift everything I needed to lift, which is why everything was built the way it is. But it was fun to build it. So, and I've got other projects that I'm doing. Obviously, like the one we just saw today that I flew indoors. I've got some rockets I'm working on. That's the size of the fan for the other one that's sitting outside. It's already built. I've got this one here that I'm working on so that I can... the aerodynamics of this was why I was drawn to it. I know there was a lot of people that were like, that's a drone that they use for, it's a one-way drone, it's an attack drone. I said, no, it's an RC model because it's 1/3 scale. I had one person leave a comment saying, that's a weapon. I'm like, no, it's a not EPO foam. It's a printed foam model is what it is. This is out of Sane Smart, expanding foam filament. So it turned out really well, and I can't wait to get it in the air and check it out. I've got the ESC in there. We're going to be running 6S 5,000 milliamp battery. Flight controller will sit there. I'm waiting for a couple more carbon fiber spars that go in the rear here, and all the servos and everything mount to the wing. And then you've got this here, so the spar goes through there and through there, So it'll be fun. Put some cameras on this, fly it around. And it's more of a loiter aircraft. And it's designed for me to experiment with different battery packs and power supplies with different motor and propeller combinations to see what gives me the most efficient loiter time for the amps. So, for the draw on the power. And that's really the biggest thing that I'm trying to figure out with this. So it, like everything else, is an experimental platform. I want to put a camera on there. We're going to run waypoints. We're basically going to just, test it out to the fullest extent of what we can, and see how it performs. So that's one of the main things. And then, of course, we have this one here. This is more of a go to the park, have some fun, and definitely turn some heads kind of drone. Like I said, if you check out the earlier versions of this inside the playlist, you'll see what I did on here, and you'll see exactly why this one is so much fun for me to work with. So let's see if we can get this set up right here. Oh, I'll definitely keep you guys posted for sure. That's the whole point of the channel, and I try not to make, sorry, this is crooked and it's bothering me. Memberships are available, but I try not to make people pay to see what I'm doing. I would rather, if you feel like it's a project, or if you want to support the channel, you can donate however you feel like it. I have links for the Buy Me a Coffee website and all that other good stuff, but I would rather the ad revenue pay for what I'm doing, or help pay for what I'm doing, than you guys having to be out of pocket just so you can see my stuff. I'm never really gonna put anything in the members only section, mainly because I feel that's, honestly, to me, that's a dick move. Now, I know some people do it because they want to make money, they want to make the revenue, but this is a hobby for me. This is a passion for me. It always has been. And to share it with everybody is part of that. It's about making a community that people can enjoy. And those who can spend will spend. If they want to donate, if they want to give something, then more power to you. I appreciate everything that comes in, because it's just going to go to buying more stuff for the projects. And I have several other projects besides what's sitting here that are in the works. They've already been designed up here. They've already been logged and written down. Starting CAD work on them. It's going to be some interesting stuff. But I'm having a lot of fun doing this. And I'm having a lot of fun showing everybody these projects and just having a blast with it, and trying to get people thinking, trying to get people to come up with new ideas, and kind of push the boundaries of what's practical until it becomes practical and efficient. So that's the whole point. I do have a Patreon, yes. I haven't posted a lot of stuff on there yet because, again, I'm doing everything. I'm doing everything from the video editing to the videos. I'm doing everything as far as designing and building the aircraft. This is a one-man show. This is literally a one-man show. From conception of the aircraft, to buying the parts, to building the aircraft, to testing the aircraft, to programming the aircraft, to doing the videos, editing the videos, setting up the shots, going to Premiere Pro and getting everything put together and edited and then outputted and then uploaded to YouTube, and with the right titles and the right descriptions and the right hashtags, and making sure that it meets monetization requirements. It's a one-man show from start to finish, and I've been doing it for a few years now, and sometimes I have to promote a video here and there, because not a lot of people jump online and say, I'm going to YouTube to look for EDF drone. Nobody does that. So sometimes you got to push it out there. And So I do that sometimes. That costs me a little bit. But it's worth it to get people to come in and say, this is worth watching. I kind of like what I'm seeing. And I want to see more of it. And that's, I want to inspire people to do those projects they think in their mind aren't going to work, and to bend physics as much as you can. Because it's the only way we're going to move forward with technologies, is to bend physics until it gives up and says, okay, I'll work. So that's the whole point. There are no boundaries here, just speed bumps. We'll get over them. Unless you're in a C8, and then you got to worry about your undercarriage. Anyway, the point is, push the boundaries. That's the whole point. Because when I had criticism for this, I didn't take it as criticism. I thought that they were like, I think one of the first criticisms was, oh, that's a huge battery pack. It could power my whole fleet. I'm like, if my little 6,000 milliamp battery can power your whole fleet, then what are you running? Like little Temu drones or something? And he seemed upset over the fact that I had designed this and made this, and he called it obtuse and it'll never work. I flew the first one for 5-6 minutes on the one charge, and it came in at 6 pounds total for the aircraft, but it could lift another 4. So that was pretty good. But it wasn't designed. I didn't design this one to lift anything. I just designed it to be fun, and I designed it with ports on the side so I could print airfoils, so I could put different types of airfoils on it and then bank it at almost 90 and then just punch it and see what it does. And this ends up being the core to different aircraft. So, oh man, thank you. I appreciate it. I appreciate you. You rock. Thank you, Explorer. Thanks for this live and sharing. I will definitely always share what's going on, and I will definitely be doing more lives. When I was building the drone for DARPA, I wasn't posting a lot of videos or doing lives because there was so much I had going on in getting that drone completed. Because I was doing it solo, I didn't get to post a lot. So since that's passed and I'm getting back into other things and I'm picking up other, programs with DARPA Connect, hopefully, and I wanted to get back into what I originally got into this for, and that was to build really cool stuff that looks ridiculous at first glance, but then when you see it in the air, you're like, that's cool. We can pop airfoils on that, bank it, and bank it and book it. So, yeah. Thank you for that, Explorer. I appreciate it. Yeah, it was. I realized when I was doing the project that I was constantly, I would get up in the morning and I would be, okay, I've got this I have to accomplish today. And for the few months I was building it before the competition, that's all I was doing. Was just, I got to get this done, I got to get that done, I got to get this test done, I got to get that test done. I got to, it was just insane. My head was around it. That I was basically, since I'm, like I said, I'm on vet benefits, so I don't have a full job. This is my full-time job, or at least what I'm trying to make it. And I would get up, have breakfast, and I would come in here, and this is what I would do. And it would be 114 in here, and I'd still be working. It was so hot. I was like thankful when it would get cooler, because and now I'm still thankful. I'm like waiting for it to get cooler now, but you know, because it's only about 100 in here right now with the sun coming down on the roof. But I am going to be moving pretty soon. So the shop's going to be about twice the size. I'm going to be, you know, up in the mountains, so it's going to be a little bit cooler during the summer. I think it tops out at about 85, but I'm looking forward to snow in the winter. I'm looking forward to, you know, a white Christmas for my daughters, and my wife wants to have the wood burning stove, and that mountain life is kind of like what I'm into. But at the same time, the silence of the mountains will be broken every once in a while when I launch a prototype, and my neighbors might not like me very much once I get up there, but I'm looking forward to it. I'm looking forward to it because it's just the kind of life that I want to live. I want to go out without the light pollution. I want to look at the stars, because that's the universe is just mesmerizing to me, and it's all of that. It's everything. I just have this hunger for knowledge. So testing these things, from the drone to being able to go outside with, you know, a cup of coffee late at night. I know that sounds weird, but I can't sleep without coffee. And then looking up at the stars, you know, unobstructed from the lights, and just being able to enjoy all of that, and still do what I love, and be with my family, and have that white Christmas with the snow finally. Because I have huskies, and it's hot down here, so like they're gonna love it up there when they get to the snow for the first time, because I've had them since they were, you know, young, and I want to give them that opportunity to see snow too. So it's not just for me. It's for my family. It's for my animals that I love. It's for, you know, it's for the atmosphere. And that's what it's finding that peace and still being able to do what you love doing, and not being stressed about bills and things like that. I don't care about any of that. I'll pay what I have to pay, and if I've got a little bit left over, I got a little bit left over. It's all that matters. Keep everybody fed and happy, and keep doing what I'm doing. And hopefully I can come up with something. Well, I actually already have, because I'm gearing this project, the Strike Heavy, towards search and rescue operations for maritime search and rescue and flood victim relief, and for any situation that requires a fast response vehicle that can go directly into VTOL and still extract a human being from a precarious situation, or render aid in maritime situations. I have several plans for that. If a ship goes down, if somebody's out to sea, if they're having issues, things like that. So there's tons of applications for, and it's part of what I've been setting up for. Are you still getting all the emails from? Yeah, I am. I did the SBIR. Investor matchmaking I'm working on, but I have to. Yes, NASA Go Aero is one of the ones that I'm working on, and that's one of the things I'm going to be applying for grants for. So I'm getting my Strike Heavy proposal for that, and that's kind of what I was discussing, was the search and rescue operations platform. This is definitely a search and rescue operations platform. So and since it's long range, it can go pretty far out. It can deploy, pretty far. So far, from my testing so far, it can deploy pretty far. And it can carry enough weight to bring what's necessary out to the field, to map terrain for search and rescue, locate people. Fire mitigation is another one that I want to have. I want to have different. It's basically a modular platform. So there's a lot I want to do with this platform, especially the finalized version of it. When I get to that point where I'm actually molding the wings, doing carbon fiber molding and things like that. instead of just printing the pieces with my printer. The prototype, it's fine to print it out and build it the way I did. But ultimately, the idea is to have the molds that I need specifically made, which I may have to 3D print the first molds, ironically, and then do carbon fiber shell halves for the wings. And then, of course, optimize their size for the lift and everything, because I overbuilt what I had originally. But yeah, it's definitely for that search and rescue situations. Or whatever else the military feels they want to use it for. I ain't gonna say nothing. I'm just gonna build them. I mean, they wanted to lift 110 pounds. It's no coincidence to me that the Hellfire and longbow configuration weighs 110 pounds. So, I mean, hey, they're gonna do what they... Military does military. Let them do what they want to do. I'm just gonna have fun building the equipment. That's all there is to it. So, there's that to think about. But honestly, with all the people that were in the competition, I honestly hope that at one point I get to work with some of the people that were at the DARPA Lift Challenge, and maybe we can work together and collab on something even bigger. Because in the end, it's about the interests of the United States, and it's about the safety of the community. If somebody's suffering from a flood, or suffering from anything at all, that these multi-role platforms can play a part in as far as rescuing or saving lives, that's what I want to do. I joined the military to protect my country. Now that I'm home, I want to continue to contribute to protecting my country and the people in it. That is the goal. So, and with the passion that I have for different, pushing electronics and physics to its breaking point, I don't plan on quitting. This is the rest of my life. This is what I plan on doing. And if I save one person, it's all worth it. And I plan on hopefully saving a lot more. So that's what Drone Power Concepts is all about. Building a community, poking fun at Evan because he's my favorite troll, and saving lives. That's what it's about. Keeping people safe, getting them what they need in precarious situations, putting out fires before they start, or before they get out of hand, I should say, and rescuing people who need rescuing. That's all. It's all that matters. Because if we're not doing this to help each other, then what are we doing it for? So that's what we're about here. And I say we, meaning me, because I'm the only one doing it right now. Again, solo show. To continue discussing projects and helping each other out, I will find a way to send those links. Yeah, definitely. Definitely send me those links. I'll join up for sure. Because, I mean, together, we could be an unstoppable force for the good of the community and the security of our nation. And that's what matters. So, with that, we're getting up to about 105 in here. Feels really warm. So I'm going to leave you guys with one final picture of the drone. Should have had 6S motors. But it was a fun flight. I told you I was going to do it live. I did it live. I flew it live. I did not break my promise, even though the motors were wrong. And later on, we're going to be moving on to other stuff to have some fun with. So, from all of us here at DPC, which happens to be me, but saying from all of me doesn't sound appropriate. So, from all of us here at DPC, we thank you for being here for the live. Please stay informed. Subscribe, click the bell for notifications so you don't miss out on any updates or any future videos, especially when it comes to that, or that, or that, or that, or that, or anything else. You don't want to miss it. It's going to be a fun year. And going on to the New Year's, that's going to be even a better year, because I'm going to be in a bigger place, and we're going to have a cleaner shop. That's not going to be a small oven. Okay, so thank you all for being here. I appreciate your support. I appreciate every one of you. I will see you all next time. I've been DPC, still am, probably going to be forever. See you next time. Have a wonderful weekend. Love you all. Peace.